Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the first principle or the limit formula for slope of tangent. As per the problem, show that at the points of intersection of the quadratic functions y equals x squared and y equals 1 over 2 minus x squared, the tangents to the functions are perpendicular. The first step is to find the points of intersection for these two given quadratic functions. We should set the two given equations equal to each other and solve for x. We are able to do this because at the points of intersection, the y values will be the same for both quadratic functions. In this equation, we can gather and combine the x terms on the left side of this equation. We should start by adding x squared to both sides. X squared plus x squared is equal to 2x squared. Next, we should divide both sides by 2. We can write 1 over 2 as a division statement. Next, we can change this division statement into a multiplication statement. The denominator of 2 is 1, so we should flip the fraction 2 over 1 to 1 over 2. Next, we should apply square root to both sides. I get plus minus square root of 1 over 4, which can be simplified to plus minus 1 over 2. So there are two x values at which the two given quadratic functions intersect. We have to prove that at these two x values, the tangents to the functions are perpendicular. Next, we should find the expressions for slope of tangent to the two given quadratic functions using the first principle or the limit formula for slope of tangent. Let's start with y equals x squared. The formula for slope of tangent is f at x is equal to x squared. The given equation for the function f at x plus h is equal to x plus h squared. We replace x with x plus h. We can expand the square on x plus h. We should multiply x plus h by itself. We can distribute the terms in the parentheses using the FOIL method. X times h can also be written as h times x, which is equal to hx. We can combine the like terms. Hx plus hx is equal to 2hx. This is the expression for f at x plus h. We can sub in these expressions in the limit formula. We can cancel out the x squares in the numerator expression. Next, we can factor out an h from the numerator expression. We can cancel out the h in the numerator and denominator. Now we can apply the limit. We should sub in h as 0. So the expression for the slope of the tangent to the function y equals x squared is 2x. Next, we can find the expression for slope of tangent to function y equals 1 over 2 minus x squared. We can use the same limit formula. F at x is the given function equation 1 over 2 minus x squared, and f at x plus h is equal to 1 over 2 minus x plus h squared. As per our analysis for the first function y equals x squared, x plus h squared is equal to x squared plus 2hx plus h squared. We can use this expression in f at x plus h. So f at x plus h becomes equal to 1 over 2 minus x squared plus 2hx plus h squared. Now we can sub in the expression for f at x and f at x plus h in the limit formula for slope of tangent. Next, we can get rid of the parentheses in the numerator. Because of the negative sign in front of the parentheses, we should change the sign of all terms inside the parentheses when we get rid of the parentheses. Now we can combine like terms in the numerator. We can cancel out half and negative half. We can cancel out negative x squared and positive x squared. Next, we should factor out an h from the numerator expression. We can cancel out the h's from the numerator and denominator. Now we can apply the limit. We should sub in h as 0. I get m equals negative 2x. This is the expression for slope of tangent to the quadratic function y equals 1 over 2 minus x squared. Now we can use the x values we got for the points of intersection to check whether the tangents are perpendicular at these x values. Let's start with x equals 1 over 2. We should sub in x equals 1 over 2 in the expressions we got for the slope of tangent to the two functions. For the function y equals x squared, the expression for slope of tangent is 2x. We sub in x as 1 over 2 I get the slope of tangent as 1. Next, we should sub in x as 1 over 2 in the expression for the slope of tangent for the function y equals 1 over 2 minus x squared. The expression we got is negative 2x. We should sub in x as 1 over 2. Negative 2 times 1 over 2 is equal to negative 1. So the slopes of the tangents are 1 and negative 1. These two slope values are negative reciprocal of each other. That proves that the tangents are perpendicular at x equals half. Now we can do the check for x equals negative half. We should sub in x equals negative 1 over 2 in the first expression for slope, m equals 2x. 2 times negative half is equal to negative 1. Next, we can sub in x equals negative 1 over 2 in the other expression for slope of tangent. Negative 2 times negative half is equal to positive 1. So the slope values we got are negative 1 and 1, and these values are negative reciprocal of each other. Therefore, the tangents are perpendicular to each other at x equals negative 1 over 2. So this proves that at the points of intersection of the given quadratic functions, the tangents to the functions are perpendicular. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.